Place a polished gemstone under a narrow beam of light, and something unusual happens. A thin luminous line suddenly appears across the surface of the stone. Tilt the gem slightly. The line moves, not like a reflection, not like a shadow. It glides across the crystal as though the light itself were trapped inside. In gemology, this phenomenon is called chatoyancy, the cat's eye effect. It occurs when thousands of microscopic fibers inside a gemstone align in the same direction, forcing light to concentrate into a single moving band. Some stones show the effect faintly, others reveal it with startling clarity, but one gemstone, the stone at the very top of this list, produces a cat's eye so precise that gemologists often use it as the benchmark for the entire phenomenon. Today we're exploring 10 gemstones capable of creating this moving line of light, from surprisingly common minerals to one extraordinary crystal where the effect becomes almost perfect. And once you notice it, you begin to see it everywhere. Let's start with number 10. Ranked 10th, quartz cat's eye, the familiar mineral that hides a moving line of light. Quartz is one of the most widespread minerals on Earth. It forms in mountains, riverbeds, volcanic systems, and even the sand beneath ordinary soil. Because of that familiarity, quartz is rarely expected to produce anything visually extraordinary. Most people associate it with transparency, gentle color, or simple decorative stones. Yet under very specific geological conditions, quartz can develop a structure capable of producing one of the most fascinating optical effects in gemology: a narrow, luminous band of light. When a piece of quartz containing aligned fibrous inclusions is cut into a smooth domed surface, what gem cutters call a cabochon, something remarkable begins to appear under a focused beam of light. Instead of scattering across the surface, the reflection compresses into a single bright line, stretching from one side of the stone to the other. Tilt the stone slightly. The line moves. Shift the light source. The line slides again, gliding across the surface like a narrow beam traveling through the crystal. This phenomenon is known as chatoyancy, derived from the French phrase meaning the eye of a cat. Inside the quartz, thousands of microscopic fibers, often rutile or other needle-like minerals, lie arranged in nearly perfect parallel alignment. These tiny internal structures act like a field of mirrors all pointing in the same direction. When light strikes them, the reflections combine into a single concentrated band. The result is subtle compared with rarer gemstones, but unmistakable once seen. Soft gray varieties often display the effect most clearly, although honey-colored and greenish stones occasionally show it as well. Because quartz occurs so widely in nature, this becomes the cat's eye effect that many collectors encounter first when learning about optical phenomena in gemstones. But that familiarity also hides an important detail. Quartz produces only a gentle introduction to chatoyancy. The luminous line is usually soft, sometimes slightly blurred, and rarely razor-sharp. In gemology, the finest cat's eye gemstones display a much more dramatic version of the effect. A beam of light so precise it appears almost drawn across the surface. And those stones are still ahead in this countdown. Before moving to the next gemstone, curiosity naturally arises among viewers who enjoy examining stones closely. Has a gemstone ever been seen where a thin line of light appears and follows the stone as it moves? Many collectors first notice the phenomenon in surprisingly ordinary minerals, sometimes without realizing what they are seeing at the time. Observations like that often become the beginning of a deeper interest in gemstone optics, because as the next stone reveals, when the internal structure becomes more organized, the cat's eye effect grows far more striking. Ranked 9th, garnet cat's eye. When a brilliant gemstone hides a moving line of light, garnet is usually associated with brilliance. Deep reds, warm browns, and fiery oranges are the colors most people recognize immediately when this mineral family appears in jewelry. For centuries, garnets have been admired for their ability to reflect light in sharp flashes across faceted surfaces. But occasionally, nature arranges the crystal structure differently. Instead of producing sparkle, the gemstone begins to guide light in a completely different way. Inside certain garnets, microscopic, needle-like inclusions can grow in nearly parallel alignment during the crystal's formation deep within the earth. These internal structures are invisible to the naked eye, yet they dramatically change how light behaves inside the stone. When such a garnet is cut into a smooth dome rather than a faceted shape, something unexpected appears. A narrow band of light forms across the surface. At first it may seem like a reflection from the light source, but the moment the stone is rotated, the illusion becomes clear. The bright line does not stay still. It slides slowly across the gem, tracking the movement of the stone itself. This is the cat's eye effect in action. Unlike quartz, where the line often appears soft or slightly diffused, garnet can sometimes produce a stronger and more defined band. In darker varieties, particularly those with rich brownish-red tones, the contrast between the glowing line and the surrounding body color becomes more noticeable. The result is subtle but striking. Gem cutters searching for this effect must study the internal orientation of the inclusions carefully. The stone has to be shaped so that those microscopic fibers run precisely across the base of the cabochon. If the alignment is even slightly off, the luminous band disappears entirely. That delicate balance is one reason cat's eye garnets are not commonly seen in jewelry stores. The conditions required inside the crystal are already rare, and the cutting process leaves very little room for error. For collectors interested in optical phenomena, however, these stones represent an important step in understanding how chatoyancy develops. Quartz shows the beginning of the effect. Garnet shows how the line of light can become stronger when internal structures align more precisely. Yet even this is far from the most dramatic form of the phenomenon. In some gemstones, the internal fibers become so densely organized that the cat's eye appears almost perfectly drawn across the surface. Bright, razor sharp, and impossible to ignore. That level of precision begins to appear in the next gemstone in this countdown. Before moving on, an interesting question often comes up among gem enthusiasts and collectors. Have you ever noticed a thin band of light moving across a gemstone before, perhaps without realizing what it was? Moments like that are often the first time people encounter chatoyancy, sometimes years before discovering what causes it. Ranked 8th. Diopside cat's eye, when a dark crystal suddenly reveals a beam of light. At first glance, diopside rarely attracts attention. Compared with the vibrant blues of sapphire or the fiery flashes of garnet, most diopside crystals appear quiet and understated. Many specimens are dark green, sometimes nearly black, with little of the sparkle normally associated with gemstones. Yet under the right conditions, this seemingly modest mineral can produce one of the most striking optical surprises in gemology. A sharp line of light suddenly appears across its surface. When certain diopside crystals grow deep within metamorphic rocks, they may trap long, needle-like inclusions that align in nearly perfect parallel directions. These microscopic structures remain invisible to the naked eye, but they form a hidden internal architecture capable of controlling how light travels through the stone. When such a crystal is shaped into a smooth cabochon and placed beneath a focused light source, the transformation becomes obvious. A narrow, luminous band stretches across the center of the gem. Unlike the softer glow seen in many quartz cat's eye stones, diopside can produce a much more concentrated beam. Against the darker body color of the mineral, the line often appears bright and sharply defined, almost as if a thin thread of light had been drawn across the surface. Rotate the gemstone slowly. The line glides with it. The motion feels almost mechanical, yet the effect is entirely natural, a consequence of thousands of tiny internal fibers reflecting light in the same direction at the same time. This phenomenon illustrates one of the most fascinating principles in gemstone optics. The clearer the internal alignment of those microscopic structures, the stronger the cat's eye effect becomes. In well-formed specimens, the luminous band can appear so distinct that it seems suspended just above the surface of the stone. The darker body color surrounding the line enhances the contrast, making the movement even more dramatic as the gem shifts under light. Because of that visual intensity, cat's eye diopside has long attracted the attention of collectors interested in optical gemstones rather than traditional brilliance. Still, even diopside represents only a middle step in the evolution of this phenomenon. Nature is capable of organizing internal crystal structures with even greater precision. In some minerals, those microscopic fibers become so perfectly aligned that the resulting cat's eye line appears brighter, narrower, and far more controlled. That level of optical order begins to appear in the next gemstone on this list. and it introduces a mineral that many collectors encounter only rarely, yet one capable of producing a remarkably elegant cat's eye effect. Before continuing, curiosity often emerges when observing stones like this under direct light. Does the moving band appear stronger in darker gemstones, or does it become more noticeable in lighter colors? Collectors who have examined several cat's eye stones often notice the contrast behaving in surprising ways, and the next gemstone offers an interesting example of that difference. Ranked 7th, Scapolite cat's eye, the rare mineral that guides light through hidden channels. Scapolite is not a gemstone most people recognize immediately. Even among mineral collectors, it often remains overshadowed by more famous stones such as sapphire, tourmaline, or garnet. Yet within geological circles, scapolite has long been known for something far more unusual than color or brilliance. Under the right conditions, it can guide light through the crystal in a remarkably controlled way. Deep within certain metamorphic environments, scapolite crystals grow slowly under intense pressure and temperature. During this process, the mineral structure can develop tiny hollow channels or tube-like inclusions that run parallel through the crystal. These microscopic pathways are invisible to the naked eye, but they have a dramatic influence on how light behaves inside the stone. When a scapolite crystal containing these aligned structures is cut into a cabochon, something unexpected begins to emerge. A thin line of light appears across the surface. Unlike the darker cat's eye effect seen in stones such as diopside, scapolite often displays warmer body colors, honey yellow, soft golden tones, and sometimes delicate shades of lavender or gray. Against these lighter colors, the luminous band appears softer, almost glowing rather than sharply cutting across the stone. Tilt the gem under a focused beam of light and the effect becomes unmistakable. The line moves. It slides slowly from one side of the stone to the other, tracking the direction of the internal channels that guide the reflection. The motion feels smooth and controlled, as though the gemstone itself were quietly directing the light across its surface. In gemology, this is another example of chatoyancy. Yet each mineral expresses the phenomenon in its own way. In scapolite, the effect tends to appear elegant and refined rather than dramatic, creating a gentle band that glides across the cabochon. Because scapolite crystals capable of producing this effect are uncommon, fine cat's eye examples rarely appear in the commercial gem market. When they do, they often attract the attention of collectors interested in unusual optical phenomena rather than traditional gemstone brilliance. And this is where the progression of the cat's eye effect begins to reveal something fascinating. As the internal structures inside different minerals become more organized, the luminous band becomes more precise. In some stones, the line appears soft and diffused. In others, it grows brighter and sharper as the internal fibers become more tightly aligned. That gradual evolution is what makes this phenomenon so intriguing to study, because further along this list, the alignment of those microscopic structures becomes even more remarkable, producing cat's eye lines that appear stronger, brighter, and far more vivid than anything seen so far. And the next gemstone introduces something completely different into the equation: color. Before continuing, gemstone enthusiasts often begin to notice something interesting when examining cat's eye stones. Does the clarity of the crystal strengthen the effect? Or does the presence of inclusions actually make the phenomenon possible? The answer becomes clearer in the next gemstone, where color and internal structure combine to produce a far more vivid version of the moving line of light. Ranked 6th, Apatite cat's eye, the gemstone where color makes the light move. Most gemstones that produce a cat's eye effect tend to share one thing in common: muted colors. Grays, browns, and darker tones usually make the moving band of light easier to notice. Because of that, the phenomenon is often associated with stones whose beauty comes from subtle optical behavior rather than vibrant color. Apatite breaks that expectation almost immediately. Even in ordinary specimens, apatite can display colors that feel unusually intense for a gemstone. Vivid ocean blues, tropical greens, and shades that appear almost electric under light. In gem displays, these colors often catch the eye long before the stone is examined closely. But occasionally something else appears inside the crystal: a narrow band of light. When certain apatite crystals grow, extremely fine needle-like inclusions can develop along a single direction inside the stone. These microscopic structures are normally invisible, yet they act like a field of tiny mirrors arranged in parallel. When the crystal is cut into a smooth cabochon and placed beneath a concentrated light source, those mirrors begin reflecting light together. Suddenly, a bright line forms across the surface. Against apatite's vivid body color, the contrast can be dramatic. Instead of a soft glow drifting across a dark stone, the cat's eye band appears almost like a thin beam slicing through bright blue or green crystal. Tilt the stone slowly beneath the light. The line slides across the surface with it, moving from edge to edge as though the gemstone were quietly guiding the beam. This combination of strong color and moving light gives apatite cat's eye stones a particularly lively appearance. In some specimens, the luminous band seems almost metallic against the saturated background, producing an effect that feels far more dynamic than many earlier examples of chatoyancy. Yet finding apatite capable of producing this effect is far from easy. Most crystals form without the aligned internal structures necessary to guide light in this way. Even when the inclusions are present, the gem must still be cut at exactly the right orientation for the cat's eye band to appear clearly. Because of that delicate balance, well-defined apatite cat's eye stones remain uncommon in the gem market. Collectors interested in optical phenomena often find them fascinating precisely for this reason. The stone combines two visual elements that rarely appear together: strong color and controlled light movement inside the crystal. But the next gemstone in this countdown introduces something even more surprising. It comes from a mineral normally celebrated for its clarity. And in that stone, the presence of internal structures that create a cat's eye feels almost contradictory. Before moving forward, gemstone enthusiasts sometimes notice an interesting difference when examining these stones under light. In darker minerals, the cat's eye line often appears sharper. But in vividly colored stones like apatite, the effect can feel more dramatic simply because the color makes the moving band impossible to ignore. And the next gemstone reveals how clarity itself can change the way that moving line of light appears. Ranked fifth, Aquamarine cat's eye. When clarity suddenly reveals a hidden line of light, aquamarine is usually admired for one defining quality: clarity. The most valued specimens are celebrated for their clean, transparent crystal structure, pale blue light moving freely through the stone with almost no visible internal features. Because of this, aquamarine is traditionally cut into sharp facets designed to showcase its transparency and brilliance. For that reason alone, the appearance of a cat's eye effect inside aquamarine feels almost contradictory. The phenomenon requires internal structure, and aquamarine is known for having almost none. Yet in rare cases, nature forms the crystal slightly differently. During growth deep within granite-rich geological environments, extremely fine hollow tubes can develop along a single direction inside the beryl crystal structure. These microscopic channels are invisible to the naked eye, but under the right lighting they reveal themselves in a remarkable way. When such a crystal is cut into a smooth cabochon and placed beneath a focused beam of light, a thin band slowly appears across the surface of the gem. The effect does not announce itself immediately. It emerges gradually, almost like a faint beam forming within the pale blue crystal. Then the stone is tilted, and the line moves. Across the surface of the aquamarine, the luminous band glides quietly from one side to the other, following the orientation of the internal tubes hidden inside the crystal. Against the gem's transparent blue body color, the effect can feel unusually delicate, less dramatic than darker stones, but striking precisely because of the crystal's clarity. It is a reminder that even the cleanest gemstones may contain structures invisible at first glance. For gem cutters, aquamarine cat's eye stones present a rare opportunity. Because most aquamarine crystals are valued for transparency, very few are ever shaped into cabochons where chatoyancy can appear. Only crystals containing the correct internal orientation will reveal the effect when cut this way. As a result, well-defined aquamarine cat's eye specimens remain uncommon. Collectors interested in optical gemstones often find them fascinating for this very reason. The phenomenon appears where it seems least likely, inside a crystal famous for its purity. And this introduces an important shift in the countdown. Up to this point, the cat's eye effect has appeared mostly in stones, where internal inclusions are expected. But further along the list, the phenomenon begins appearing in gemstones capable of producing far more dramatic visual behavior. In fact, the next mineral belongs to one of the most complex gemstone families known in geology. And within that crystal structure, the moving line of light can become noticeably stronger. Before continuing, gemstone collectors sometimes notice something interesting when examining cat's eye stones under the same light source. Some gems reveal the effect immediately. Others hide it until the angle is just right. Moments like that often remind observers how much of a gemstone's beauty depends on the invisible architecture inside the crystal. And the next gemstone reveals how that architecture can create an even more pronounced version of the cat's eye phenomenon. Ranked fourth, Tourmaline cat's eye, when crystal complexity begins to control light. Few gemstone families are as structurally complex as tourmaline. Within a single mineral group, tourmaline can appear in nearly every color imaginable: deep forest green, golden yellow, soft pink, electric blue, and sometimes several colors inside the same crystal. This remarkable diversity comes from the mineral's complicated chemical structure, which allows different trace elements to influence the crystal as it forms. Because of that complexity, tourmaline has long fascinated gemologists, but color is only part of the story. Under certain conditions, tourmaline crystals develop internal structures that guide light in a very precise way. During the crystal's growth, extremely fine parallel fibers may form along one axis of the mineral. These microscopic features are almost impossible to detect with the naked eye, yet they can dramatically change how the stone interacts with light. When such a crystal is cut into a cabochon rather than faceted, the effect becomes visible. A bright band of light appears across the surface. Unlike the softer cat's eye effects seen earlier in the countdown, tourmaline often produces a more concentrated line. The luminous band can look sharper, almost as if a narrow ribbon of light had been drawn across the gem. Move the stone beneath a focused light source. The line follows. Sliding slowly from one side to the other, the cat's eye band tracks the orientation of the internal fibers hidden within the crystal structure. In darker varieties of tourmaline, particularly deep green or brown stones, the contrast between the glowing line and the surrounding body color can be striking. This is where chatoyancy begins to look far more deliberate. The line appears controlled, confident, and easy to observe, even with small movements of the gem. Compared with earlier stones in the list, the phenomenon begins to feel less subtle and more visually dramatic. For collectors interested in optical gemstones, tourmaline cat's eye stones represent a fascinating transition point. The mineral's complex structure makes it far more likely for aligned inclusions to develop during growth. Yet the gem still requires careful cutting. The orientation of the internal fibers must be perfectly aligned with the base of the cabochon. Otherwise, the luminous band disappears completely. When the alignment is correct, however, the result can be remarkably elegant. A clear cat's eye line gliding smoothly across richly colored crystal. But the countdown is approaching a point where the phenomenon becomes even more unusual. Because the next gemstone does something extremely rare in gemology. It combines two optical effects inside the same crystal: a moving cat's eye band and something else entirely. Collectors who encounter such stones often describe the moment as surprising, because the gemstone appears to change its identity depending on the light around it. And that unusual behavior begins to appear in the next entry on this list. Ranked third, Alexandrite cat's eye, when one gemstone performs two optical miracles. In the world of gemstones, Alexandrite already has a reputation for doing something extraordinary. Under daylight, it often appears green. Under incandescent light, the same crystal can shift dramatically toward deep red or purplish tones. This remarkable color change, caused by the way chromium inside the crystal absorbs and reflects different wavelengths of light, has fascinated collectors and gemologists for generations. Because of this phenomenon alone, Alexandrite is already considered one of the most intriguing gemstones in existence. But in extremely rare cases, Alexandrite reveals a second optical behavior, a moving cat's eye line. When certain crystals form, microscopic needle-like inclusions align themselves within the Chrysoberyl structure that Alexandrite belongs to. These tiny internal features become organized in such a way that they guide light along a single direction inside the stone. When the gem is cut into a cabochon and placed beneath a focused light source, the result can be astonishing. A narrow, luminous band appears across the surface. Tilt the stone slowly. The line moves. But in Alexandrite, something even more unusual begins to happen. As the lighting environment changes, from daylight to warmer indoor illumination, the entire body color of the gemstone shifts, while the cat's eye band continues sliding across the surface. Green becomes reddish, yet the line of light remains, two optical phenomena unfolding inside the same crystal. For collectors who specialize in unusual gemstones, Alexandrite cat's eye stones represent one of the most fascinating combinations in gemology. The rarity comes from the fact that both conditions must occur together: the chemical composition required for color change and the internal alignment necessary for chatoyancy. Each on its own is uncommon. Together they become exceptional. Even experienced gem collectors sometimes encounter only a handful of such stones during their lifetime. When well-cut specimens appear, the cat's eye line can glide across a gemstone whose color itself seems to transform depending on the surrounding light. It is a reminder that minerals formed deep inside the earth can contain astonishingly complex internal structures. Yet the countdown is now approaching stones that many people recognize immediately, because the next gemstone in this list is probably the most familiar example of a cat's eye effect ever seen in jewelry. Golden bands of light moving across its surface have made it instantly recognizable, even to people who have never studied gemstone optics. And its appearance has inspired its name. The stone at number 2 is tiger's eye. Ranked second, tiger's eye, the stone that made the cat's eye effect famous. Long before most people learn the word chatoyancy, many have already seen the phenomenon, often without realizing it, because one gemstone has carried that moving band of light into jewelry shops, souvenir markets, and mineral collections all over the world. Tiger's eye. Unlike many gemstones earlier in this countdown, tiger's eye does not hide the cat's eye effect quietly. The phenomenon appears immediately, bold and unmistakable. A golden band of light sweeps across the surface of the stone, gliding from one side to the other as the gem tilts beneath illumination. The effect feels almost alive. Under a steady beam of light, the band moves like brushed metal catching sunlight, shifting smoothly across layers of warm gold and deep brown. Even a small movement of the stone makes the luminous lines slide across the surface, creating the illusion that the gem itself is watching the light move around it. This striking visual behavior is the reason the stone earned its name. Yet the story of tiger's eye is not just about appearance, it is also about geology. The mineral begins its life as chrysoberyl, a fibrous form of asbestos. Over long geological periods, those fibers are gradually replaced by silica while preserving their original structure. The result is a quartz-based stone that retains the perfectly aligned fibrous pattern of the original mineral. That preserved fiber alignment is what makes the optical effect so clear. When light strikes the polished cabochon surface, reflections from thousands of microscopic fibers combine into a single bright band that moves across the stone. Because the structure is so uniform, tiger's eye often produces one of the most visible examples of the cat's eye phenomenon found in nature. For this reason, it has become the stone many people first associate with the effect. From carved talismans in ancient cultures to polished cabochons in modern jewelry, tiger's eye has introduced generations of collectors to the strange illusion of light moving across a solid crystal. Yet within the field of gemology, tiger's eye represents something slightly different. It is the most recognizable example of chatoyancy, but it is not the most precise. Because in one particular gemstone, the internal structure responsible for the cat's eye phenomenon becomes even more perfectly organized. The luminous band appears brighter, sharper, and more controlled than in almost any other mineral. So precise, in fact, that gemologists often treat it as the standard by which all cat's eye gemstones are judged. And when that stone appears under light, the result is not simply a moving band. It becomes something closer to a beam of light suspended inside the crystal. That final example waits at the very top of this list, and it is the gemstone known simply as cat's eye. In first place, Chrysoberyl cat's eye, the gemstone that defines the phenomenon. In gemology, the term cat's eye does not always require explanation. When spoken without a mineral name attached to it, the phrase traditionally refers to one stone above all others, Chrysoberyl. Long before the science of optical phenomena was fully understood, collectors had already noticed something remarkable about certain chrysoberyl crystals. When cut correctly and placed beneath a focused beam of light, the gemstone produced a luminous band so precise that it appeared almost suspended within the crystal itself. Not soft, not diffused, but sharp, bright, and unmistakably controlled. Across the domed surface of the stone, the line forms with extraordinary clarity, stretching from one edge of the gem to the other, like a beam drawn across polished glass. Slowly rotate the cabochon under light, and the band glides smoothly across the surface, perfectly tracking the movement of the stone. The effect feels almost mechanical in its precision, yet it is entirely natural. Deep inside the chrysoberyl crystal, thousands of microscopic, needle-like inclusions align in parallel during the mineral's growth. These tiny structures act together like a field of perfectly oriented mirrors. When light strikes them, the reflections combine into a single concentrated band. The stronger the alignment, the sharper the result. In the finest specimens, the phenomenon becomes even more dramatic. As the stone moves beneath the light, one side of the gem suddenly appears bright and luminous, while the opposite side darkens noticeably. Gemologists refer to this striking contrast as the milk and honey effect. Half the stone glows, the other half deepens in tone, and the dividing line between them, thin, bright, and perfectly defined, moves with the gemstone as though the light itself were sliding through the crystal. This level of optical precision is what makes chrysoberyl the benchmark for chatoyancy. While many gemstones can produce a cat's eye effect, few achieve the same sharpness, brightness, and balance that chrysoberyl displays when the internal structures are perfectly aligned. Because of this, the stone occupies a unique place in gemology. Quartz may introduce the phenomenon, tiger's eye may make it familiar, but chrysoberyl reveals it in its most refined form. For collectors who specialize in optical gemstones, encountering a fine chrysoberyl cat's eye under direct light is often unforgettable. The movement of the luminous band feels deliberate, almost engineered, yet the structure responsible formed naturally deep within the earth millions of years ago. A single beam of light moving across solid crystal. A quiet demonstration of how precisely nature can organize matter at the microscopic scale. And it is this extraordinary alignment of structure and light that gives chrysoberyl its reputation as the true cat's eye gemstone. Among all stones capable of producing chatoyancy, this is the one that defines the phenomenon itself. Sometimes all it takes to reveal that hidden architecture is a single beam of light. And once the eye learns to recognize the effect, it becomes surprisingly easy to spot. A flashlight, a small polished stone, a thin line suddenly appearing where it wasn't before. Many gemstone collectors remember the exact moment they first noticed it. The quiet instant when a crystal under light suddenly revealed a moving band across its surface. And after seeing it once, the question naturally follows, which gemstone produced the most perfect cat's eye you've ever seen?